Bismillahirrahmanirrahim. June 2025, 43 variant complete mechanics paper. We are going to start question number 1. What are question number 1 we have, students? He mentioned here two particles, P and Q. P mass is 0.1 and Q mass is 0.3. Are the rest in a smooth, means no friction at all. P is projected towards Q with speed of 4u. Okay, I think I have to start some work like this. Okay. Okay, copy. So before collision, and then we have naturally after collision. Okay. What question we have? He said there are two. There's a P particle, there's a Q particle. P mass 0.1, Q mass 0.3. So 0.1, 0.3, P and Q. And he says that P is thrown with a 4u speed. What speed? 4u. At the same instant, Q is projected directly towards P with speed of u. So this is a thrown towards this u speed. And I taught many times in my previous lectures, whenever observer's eye is there, and you know it very well. Going away was positive, coming backwards to observer negative. Okay. And after collision, P move with the speed of 2 and Q move with the speed of 4. Find two possible values. What these two possible values? It means you have to think about two possibilities. One possibility, if lighter particle hit with the heavy particle, so two possibilities. Either after collision, it will come back, it will go away. Second option, both will move rightwards. So there are two possibilities. So I will use one by one. So first I use this one. Both are traveling rightwards. Let's assume P moves speed of 2, so this speed is 2. And Q moves speed of 4, so this is a 4. And formula is very clear. M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. So I'm going to plug in, but important interesting point is what? 0.1 times 2 U, this is a 4U. And M2 is a 0.3. Important part is about to come. That will put not U. I will plug in negative U. And M1 is 0.1 into 2. And 0.3 into 4. Okay. So right hand side, if I calculate, I got a 0.2 plus 0.3 into 4. It means it coming 1.4. Right hand side, I got a 1.4. And left hand side, I got a 0.1 into 4 and negative 0.3. So basically, I got this one, if you check it, 0.1 U. And U turns to be, if I divide by that one, so this goes down, I get a 14. So I think all of you understood well how I got the first part. The first part, I've got a 14 meter per second. So this is a first possibility. Okay. Second possibility, if I take the same diagram, everything same, and I am pasting it here. All right. But this time, this arrow will be reverse. This is reverse. So because lighter part is so 2. Now, what is same formula I use? I'm saving the time. So this into this. Right hand side will not change, but look at here, students. I will copy the whole thing as it is. Okay. So copy and I'm pasting here. Only one thing change. What is that change? This 2 is backwards. So here, negative 2, not positive 2. This is a negative 2. And rest, I'm going to find it. And left-hand side will come as it is 0.1 U. Right-hand side, check it. So 0.1 into negative 2 and plus 0.3 into positive 4. And I got a 1 and U becomes 10 meter per second. And I believe you got a point. Very clear. This is done. So let's talk about the last part of this question is the largest possible loss in kinetic energy. How we can find largest loss, okay? So we have a look at here. If we check it carefully, the difference Okay, you can see that this is very clear. We will find it kinetic energy before collision and kinetic energy after collision. Okay, so we can see here as this speed is more, okay, and this speed is less. So naturally loss is there, but he is asking the largest loss. So first of all, let's go for kinetic energy before collision, before collision. How before? So please concentrate here. I will use this data to find it, okay? So let's try to do it. What is the formula we have? Half mv square, half mv square. In the place of u, I'm putting 14. So 14 into 4, I'm getting 956, half mv square plus half m, and this is same as it is 14. So I think idea is very clear. So let me find it. Half into 0.1 into 56 square positive 1 by 2 into 0.3 into 14 square. Okay, 1 minute. Okay, so answers turn to be with me 931 over 5 joules. This is a before, okay? And what is a after comes? So I talk about this situation, okay? So thing is very clear. So because this is the same, this is the same, okay? This remains same. Only thing is we have to find it because direction is not a matter. Because when we take a half mv square, this remains same. So I will find it the other one. So what is this possibility in the other condition? This is before and after. Now let's talk about after. Half mv square. And if I plug in, this is no need to plug in because 2. Half mv square, half. Okay, so let's try to find half into 0.1 into 2 square. Okay, and plus half into m and 4 square. So this is turned to be 13 over 5 joules. Now question comes, this is a before after. If I subtract them, I get the difference. But thing is this, we have two possibilities, this and this. Okay, and if I use in the place of u, I've put 14, I've plug in 10. What happened? Scenario number 2, and what is the loss comes from here? So what is loss come from here? Subtraction. So before is always bigger and after is smaller. So because before collision, okay. So if I subtract it, just a minute, 931 over 5 minus 13 over 5. So I get it, I get it here. Let me recheck again. 931 over 5 and minus 13 over 5. So it means 931 over 5 minus 13 over 5. I got a loss 183.6 joules. Okay. Now students, in case if I take a 10, what happens then? So this will remain same after no change at all. But only thing is I will use the upper formula. Condition is a case number 1. Now I check a case number 2. Second, I will not find again, but top I'll find only. So kinetic energy before. So half, and I will take a, not 14, I will take a 10. Make sure. So 10 fours are 40. So 40 square plus, and 10 goes directly there. So this is a just finding half into 0.1 into 40 square, 40 to power 2, plus half into 0.3 times 2, 10 square. And this I'm getting 95 joules. Okay, now you just check it. If I subtract them, what happens then? 95 minus 13 over 5. And I get this answer 92. So second loss, if I subtract, because before is always bigger, this is smaller. So what is the second loss? So second loss, if I find, so 95 minus 13 over 5. And what I'm getting answer, 92.4 joules. But he said find the largest possible. So this is my answer finally, 183.6. I hope so. The concept of the question is clear. Question number 2, we have a mass of 4,500 kilogram is towing. You can see here a trailer of mass 350. Okay, so two masses, we know it well. Okay, and write data every time because data is very important. Small mistake can lead a problem. Okay, the van and trailer are connected to the light tow bar. Okay, parallel to road. The friction acting on the van is X and trailer is 120. Okay, so the driving force produced by the van engine is this much. Okay, just look at students. I just make this diagram. Without diagram, without data writing, question is nothing easy to do. Okay, this is the van, the engine working. This is a van. Okay, I think clear. Okay, van. So, and what is the driving force produced? Driving force. So I'm writing to applied force is what? 2,500 newtons. Okay. And there is for example, have a look here. Okay. And this, okay, I just mentioned here, this mass is van mass is a bigger, so 4,500 mass. And this is a 350. Okay, whenever we have a tension, suppose we have this kind of pulley questions are there. So tension always towards pulley. If we have this kind of pulley question comes, for example, so this is a two particle hanging and tension towards pulley. Same way, if you remove this wire of this wire, remove it and become straight. So tension always towards pulley. So that is why I'm writing this tension. Can you see these tensions are towards pulley, towards each other? Basically, this wire is passing over the pulley. So if I remove the pulley, I will get a tension in a string like a tension towards each other. A short story. So that is why you can see tension always in a string towards each other. I know this is the main point. Some students confuse how tensions are towards each other. So I think this part is clear. And now, interesting part. When this is moving, the friction acting on the van is X. So this is you can see this friction acting on the, so this I'm writing X Newton. And friction acting on trailer is a 120. This is a 120 friction acting on trailer. So this is a V for van. I think clear. Now you can see all components are resolved, okay, properly. Okay, and driving force, okay, what is further left behind? Acceleration whole system is if van is moving zero point 0.4, so naturally this trailer will also move with a zero point 0.4. Okay, we need to find X and T. So let's apply two formulas. First of all, I'm applying a formula for the van. Okay, get ready. So basic formula we use, net force is equals to MA. Net force is equals to MA. How many force acting on this particle? Okay, we will take this one. We will not take this tension. Okay, make sure. If we take this one, they will cancel out. So we will take these three forces. 1, 2, and 3. I'm writing now. So I'm writing 2,500 minus friction minus tension is equal to ma. What is the mass? 4,500. And what is the acceleration? You know 0.4. So I'm writing now here. So I'm getting equation minus x minus t is equals to this. I'm solving 4,500 times 2.4, and this will go on the other side. So minus 2,400, and I'm getting this negative 700. So this negative, okay, all equation, okay, I'm leaving it here for a while, okay? So let's make a same formula for it. But here we will make this concept here. Don't take tension and don't take friction, okay? So net force is equal to MA, same formula I will use, but on trailer, okay? So try to do it now. So starting from here, because motion is rightwards, you know, all of you. So tension minus friction. So tension minus friction 120 is equal to mass is 350. So 350 and acceleration is 0.4. If I bring on the other side, I will find tension easily. So 350 times 2.4 and plus 120. And I got answer 260 newtons. So this multiply by minus 1, x become positive, t become positive, and 700 become positive. If I replace a value of this is here, so I will get plus 260 equal to 700. And from 700, if I subtract this answer, I'm getting 440. So x is equals to 440 newtons. I hope so. The concept is very clear and the question is completely over. Question number 3 we have. Diagram shows a velocity time graph which model motion of particle. The graph consists of three straight lines segments. The velocity of the particle at a time after fixed point O is v, and the particle leaves O with a 5. It means you can say that this 5 is a when is the particle is leaving observer, I mean O, and acceleration 0.75. So this line gradient is 0.75. So I'm writing here. So V is given, so not V, U is for this motion starting velocity 5 and acceleration is 0.75 and for 20 seconds. So its time is equals to 20. And after having, let me read a question further. Then the particle decelerates for the next 30 seconds. So this is a 30. So 20 to 50 is called 30. So this completely is called deceleration. All right, done. And velocity of the particle is becoming 0 at 40. So it means at here velocity is 0. Particle stops and the particle starts to track back to O and come to rest at O. It means, as you know, students, when a part observer is here, when a particle is going away from observer, velocity positive. When coming back to observer, velocity negative. So this is a distance going away. This is area going away, S1 plus S2, this area while going away. And this full triangle, the area is coming while coming back, S3. So it means velocity is in because you look at here, the velocity is a negative. Here velocity is a positive. So positive velocity is going away and negative velocity is coming back. I hope so this part is very clear. But we cannot start. We need to find capital T, which T is here. So let's start this data given enough to find out a final velocity. V is equal to U plus AT. U is 5, acceleration is 0.75 and time is 20. When I type in calculator, I get a 220 meter per second. It means at this moment, the velocity is given here is 20. Okay. So it will help us to find out the area of trapezium S1. Okay, so we have to find it. But one part is very clear. Area of S1 plus S2 is equal to S3. So first of all, I will find S1 area. I can do it two techniques, either the trapezium area or use the data and finding the equation. So what is formula 2AS is equal to V square minus U square, and A is, we you know it very well, 0.75. S is a task. V, I just got it 20. And you know you 5. So by doing this, I can find S easily. So I will count S1. 20 to power 2 minus 5 to power 2 and divided by 2 and divided by 0.75. I'm getting 250 meters. So this distance is coming with us 250 meters. Okay, done. What about S2? S2, we can find two techniques, same formula or area of the triangle. And what is the area of triangle? Have a look. Area is equal to half into base into height. I am teaching all possible ways, though we can use this formula as well, but we need to find acceleration separately. And what is a base? What is a base? Base is a 40 minus 20 is 20. And height is this is a 20. So I hope so clear. And two tens are, and I got a 200 meters. So 200 meters. So S2 is 200 meters. This part is very clear. Now we know it very well. As I said, this distance is equal to this triangle distance. So how to find this triangle area? So I'm going to show you third one. Third one, I can get it. So if I talk about the full triangle, look at it, look at it. This full is called base, and this is called height with the 90 degrees there. So height, this is called height. And what is the area formula? Half into base into height. Okay, but problem is coming with us. We don't know not a base, not even height, because this velocity is unknown. Second number, this t is unknown. So how we can find it? So this formula first, we cannot work with it. So we will go for another plan. And what is another plan? There's a very tricky, and look at now, what are coordinates of this point? X is 20, y is 20. So, okay, or I can work for this line also. What this line is? This line, what is this is called starting velocity. What is the ending velocity? Problem is what we have. We don't have ending velocity. We don't have acceleration even. So what I best technique, another one we have it. What is here? 20 comma 20. Like x is 0 and x is 20, y is 20. What is this coordinate? X is 20, x is 40, sorry, and y is 0. And what is this point here? Because speed I don't know, but x is 50 I know. So we have this way also available. So have a look now how we can do it. Okay, so I think data is very clear to you students. Now it's very clear approach. When there's a straight line, is you can I just draw separate here. Okay. So I will use, students, I will use this formula m is equals to m. I use two gradients and using same line. You can see here, first of all, I will use students what? I will use, because both are given, I will use this. One time I use given and unknown. So for example, y2 minus y1, I'm writing now here, v minus 0 over x2 minus x1, I got a 50 minus 40. On the right side, I will use these two. So y2 minus y1, so I got a 20 minus 0, and x2 minus x1, so 20 minus 40. And I got v by 10, and here it is turned to be 20 by 20 is becoming -1. This is coming -1. So I got a velocity is turned to be negative now. Now, surprisingly, you may ask why negative? Because common sense, this is a below x-axis. So negative sign, I will not take it while. So height is this height. If this is a negative 10, so this height is considered from here 10. I will not take negative sign because negative is just for direction. Okay, now I think you can understand very well because I will add the two distances equal to area of this. So let's start. So area formula half into base into height. Area is this to add, we got a 450. I'm writing in the place of A. And base is I don't know, so I'm writing B as it is. Height, I take only 10, not take negative sign. So two fives are, 5 goes down. So 450 divided by 5, I got 90. So 90, okay. So now this 90 I add, because this full T I talk about, this 90 if I add in 40. You may ask why, sir, what is the reason? Because I consider this total length, this is okay. So 40 plus this 90, I get a T. So T is equals to 40 plus 90. So T is equal to 40 plus 90, and answer turns to be 130 seconds. So Alhamdulillah Rabbil Alameen. Second method, if you find gradient from here, and then you can find equation of motions also to get the velocity. Okay. So, and that reason you have acceleration for it. Starting velocity 20, last velocity we don't know, and time is 30. We can find even that way. So it works even. Okay, so and now last part of the question, find acceleration of particle when time is this to this. Not a hard job. So it means we are looking for the gradient. And what are coordinates here? X is there 130 comma 0. Why? Because velocity is 0 here. And what are coordinates of this? We have already 50 and negative 10. So I'm starting, and what is the formula? Formula given is very clear. So y2 minus y1 over x2 minus x1. So acceleration becomes, so I have two coordinates, 130 comma 0, and second I have at, I think so 50. Let me check. Here 50 and negative 10. 50 and negative. Now I must take negative. I will not eliminate minus sign. Apply formula, I'm starting here, y2 minus y1, or I start from here, no issue at all. Negative 10 minus 0 and 50 minus 130. And after typing in calculator, so 10 divided by negative 120, my answer is turns to be, wait a minute, let me check, because he asking, sorry for that, maybe. This is a great, he asked about, let me check which asking, 50T. 52T. Yes, yes, correct. Okay. So 52T. Yes, okay. So once again, I check in calculator. Negative 10 divided by 50 minus 130. And answers turn to be 1 over 8. Negative 1 over 8. Not negative, negative. We are negative, negative, positive. So we got a positive 1 over 8. Positive 108, or I can say 0.125 meter per second square. Okay, because it is a positive gradient, you can see, and the question is completely over. Question number 4, we have 3 blocks P, Q, and R. Masses 25, 20, and M. Held in equilibrium. So equilibrium point is very clear. And further, what's important sentence is not that much. Okay, we have given in diagram everything. So mass is unknown and Q is alpha is unknown. Before I start, I always give this example to understand whenever we have this kind of pulley and two vertical particles hanging. So tension always towards pulley. So if I remove the pulley from middle, so tension towards each other. Even the pulley is this way and one particle hanging here and one particle is here. So again, tension will be equals to each other and equal. Okay, so same situation we have here. So this I count as a tension 1. So this is also tension 1. And when you talk about this particle, so weight is hanging downwards and this is a tension 2. And this I will count as a tension 2 as well. They are equals to each other. So this condition, I hope so, is very clear. Now students, let's first of all, because equilibrium, this, what is the weight acting here? 25 kilogram into 10, 250. Into 10, 200. Into 10, 10 M. Okay. Condition number 1, because it is not moving, so tension 1 and 10 M equals to each other. So I replace tension 1 equals to 10 M. And what about tension 2 is equals to, I can say here, 250 newtons and newtons. Now students, nothing is left. You can see this is a particle, this is a position O. So we have 3 forces acting on that. Okay. So I'm going to make a diagram here. Is a very important tension 1. And tension 1 I replace by 10 M. Okay. This is downwards. Okay, we have is a 200 newtons is acting downward. You can see here. Okay, and one force acting is here. This is a T2, which is equals to, sorry, T2 is equal to 250. So this is a 250 newtons. And if you look at carefully, this is 30 degree and this is a alpha. Now I'm going to resolve the forces. This is a, okay, I just make a roughly x-axis, okay? Or this is a y-axis. So if alpha given here to two forces are there, one acting rightwards and one acting downwards. And this alpha is equal to this alpha. So this is 10m cos alpha. This is a 10m sine alpha. Same this one. So one force acting this way and one force acting parallel to x and one parallel to y. So this is what force is 250 angle 30. I can say 250 cos 30. I can say 250 sine 30. And 2 has 200 no component breaking because it is exactly downwards. Now, student, I can make two equations. First, I talk about horizontal components and then vertical components. So horizontal components we have horizontal. Okay, let me write slightly top. Okay, here, horizontal components. So it means right side equal to left side. So I'm writing here 10m sine alpha equals to 250 sine 30. Repeat my words. This come from here and this come from here. Okay. 10m sine alpha. And if you check it, sine 30 is a half, 125. Equation number 1 done. Now I talk about vertically. Okay. So horizontal or vertical? Okay, let's talk about the vertical. So let's try. Vertically, this upwards. So this is downward and this downwards. So I can say here 10m cos alpha plus 200 is equal to 250 cos 30. Repeat, this two sum is equal to that one. So 200 will go on the other side. And I'm getting here 10m cos alpha is equal to 250 cos 30 negative 200. 200 goes other side. Now this is equation number 2. I know that sine over cos is a 10. And if I divide 1 divided by 2, so what happens? Look, I show you. This equation I'm copying from here, I'm pasting here. And this equation I'm copying from here. Wait a minute. This I'm copying from here and pasting below. And put the equals in the middle, okay? So this equal signs, I make it one equal only and divide them. So I believe it's nothing hard to understand. This is coming up. 10m will cancel out and I get a tan alpha. This is a tan alpha. And this is the whole thing as it is. And when I take a tan alpha of this whole thing, so let's see what answers turn to be. So tan inverse, in the numerator we have 125 and down we have a 250 times 2 cos 30 minus 200. And if I check it in calculator, I'm getting 82.47756. And alpha rounding 3 as 1 dp, I got a 82.5 degree because angle always 1 dp, 1 decimal places. And then if I plug in, there's a longer value, any one equation, I plug in it here. And 10, and this I will divide. So I will write it now here. and I am writing what? So m alone 125 over 10 sine alpha. Actually, I made m subject. So this value, I'm going to plug in it here and give us direct answer. So sine of answer, then into 10 and 125 divided by answer. And my answer is coming finally 12.6 kilogram. So Alhamdulillah Rabbil Alameen. I hope so. The concept of the question is completely over. Question number 5, we have a van of the mass 2500 traveling with a speed of v and experiences of resistance kV square. So frictional force is kV square and power is 625 kilowatt. So 625 and 2 more zeros because multiply by 1000. Best way to write like this. Steady speed means acceleration is 0. The steady speed of van could maintain when moving along a straight horizontal road is 50. So this is a speed. So we have to show K is equal to 0.5. Basically, what formula we use? Net force is equals to MA. Applied force minus friction force is equals to MA. And power formula, you know, is F times 2V. If I make it F subject, so this V will go under it. So I can replace it here. Power by V minus friction is equals to 0 because acceleration is 0. And this, okay, I can plug in it later on even. So power is 62500. Speed is 50. Frictional force is kV square. I replace K, but V I replace by 50. So I got a 50 to power 2. And this is 0, so I can bring friction on other side, so equal. Now I'm going to solve it in calculator. So 625 and 00 divided by 50, and again divided by 50 to power square. And because it will come down as well. And K value is becoming half. Proved. So this part is completely over. So let's talk about the next part. Find acceleration when speed is 25. Same condition. So I will apply this formula now. Power by V minus friction is equals to MA. Power is 62500. But speed he mentions 25. And friction is kV squared. K value is a half. So I'm writing half. And V is 25 to power 2. Mass is 2500. Acceleration is my job to find. And just a matter of typing in calculator. 62500 divided by 25 minus 1 over 2 into 25 to power 2. And I'm getting here 4375 over 2. When divided by 2500, and I get answer of acceleration 7 over 8 meter per second square. Or in decimal, I can say is equals to 0.875 meters second per second square. So I hope so the concept of this part is clear and part A is clear. Part B we have the van begins to ascend a hill of angle theta to horizontal, and van travels along a line greater slope of hill. Speed of van start hill is 20 at the bottom, and acceleration is 5a. Later on, same hill, the speed of this 30 and acceleration is a. So power of the engine remains this one, and friction remains the same. So we have to find out. So let's start. So I hope so. This idea is nothing hard to okay, but this time inclined plane is playing a role. So I'll make it two diagrams. So first of all, have a look. There's applied force, frictional force, weight component, that is mg sine theta, mg sine theta, and this is a theta. And if we check it, 1 minute, let me check what is the mass. 2500, 2500, okay, 2500. So mass is 2500, okay. So because system is going upwards, he says if is moving in the 5a, and speed is what? Speed is 20. Speed is 20 and acceleration 5a. So speed is 20. V is equals to 20. So let's apply the formula. So first of all, friction. What is the friction formula? You know, half V square. So 1 over 2, and speed is 20. So I got a 20 square. So 20 square is a 400 and divide by 2. So friction in this condition is 200. Now I can apply and power formula, you know, what is the force? Force is a power by V, as I said before. So net force is equals to MA. So I can say power by V minus friction minus weight component is equals to MA. I'm going to plug in the values, students. So 62500, speed is 20, friction is 200, and mass is as 2500, gravity 10, and sine theta is unknown. So I'm leaving this as it is. And mass is again 2500, but acceleration is 5a. So I'm writing here 5a. So I am typing in calculator 62500 divided by 220 and minus 200. I got here 2925 minus 25000 sine theta is equals to 2500 into 5 becomes 12500 acceleration. This is equation number 1. Same equation I'm going to copy, or best idea, not even this. Even I'm copying everything here because I need everything same. I think slightly change only. Rest is a same, okay? I make again. Okay, so I copy this and I'm pasting here. This part is very clear. Okay, now because he said the speed is 30 now, and acceleration is a. Speed is 30, acceleration is a. Speed is 30. So 30 square. Speed is 30. Speed is 30. And acceleration is a. So a here and 30 here. So what is the 900? 900 divided by 245, 450. Now I can apply same situation. Let me check. Anything is different? Yes, no difference. So 62500. Speed is 30. Friction 450. Mass is 1200 into 10 into sine theta. Mass again 1200. Acceleration is A. Okay. Just recheck. Acceleration is A and 30. Okay, fine. So I'm going to simplify 62500 divided by 30 minus 450, and I get here in fraction form 4900 by 3 minus 12000 sine theta equal to 1200 this is a change, 12500 is a mistake. Okay, I have to write mass, how much? 2500. So to mass 2500, yes, mass 2500. Okay, so mass is a 2500. So 25000 and 2500 acceleration. Okay, so and once again 62500 over 30. Okay, over 30 and minus 450. Okay, this is very clear. Half into 30 square. Okay, now students, this is the second equation. I got it. And I'm going to cancel because this is similar, exactly same. So I just bring the top equation down and subtract them. So I'm pasting below. Okay. So when I subtract, what happens, students? So sign change. Sign change is cancel fully. And from 1 minute, yes, yes, okay, there's a 5, 22, 5, 00 and 5, yes. So this one clear. So when I subtract minus 12500 minus 2500, I get a 4 zeros. And what about the other side? 4900 divided by 3 minus 2925. I repeat, 4900 minus divided by 3 minus 2925. Okay. So, and this is yeah. So it means is the correct answer I'm getting here, alhamdulillah. 3, there's a negative sign here and negative sign here. So 3875 over 3. And when you divide this number here, what I get acceleration, students, I'm getting acceleration 31 over 240. In decimals, it turns to be 0.129, 3SF answer. But did he ask a special form? Not at all. So this is our final answer. And now how to get the angle? So I can plug in anywhere. So I will plug in this value in this equation better. So I can find easily. So I'm going to plug in the numbers there. So 4900 over 3 minus 25000 sine theta is equal. When I plug in this value here, so 2500 into 31 over 240. So I'm getting here in fraction form 3875 over 12. Now I make sine theta subject. If I find sine theta subject, so let's see what happens. This value minus 4900 divided by 3 and divided by negative 25 and triple zeros, I'm getting 629 over 12,000. And when I take a sine inverse, my answer turns to be 3.004. So 3 degree is our final answer. And I hope so. The question is completely clear. Question number 6 we have. Diagram shows vertical cross-section of ABC rough water slide. Okay. And AB is a straight of length 5 meters. You can see 5 meters. An angle theta with a horizontal and sine theta is given by him. You can see here. And B is a 2.5 meters above the level of sea. So this is a 2.5. The man of mass is a 80 kilograms given as a particle slides down, okay, and start from rest. So velocity at A is equals to 0. Coefficient of friction is mu is given 0.1. We need to find speed at this moment. So how we can find it? There are many ways to do it. Okay, first of all, because coefficient, okay, so we can find acceleration, number 1, and number 2, we can apply the magic formula as well. Okay, both works. So let's try first the Newton law technique. I think better to Newton law. Okay, Newton law technique is what? We know it very well So when you talk about a particle, okay, I can make it even here, no issue at all. When a particle, what the mass is given by him, mass of the particle is 80. 80 into 10, it becomes 800 newtons. And this is upward is R, and this downwards is a 800 sine theta. So what is the frictional force? F is equals to mu R, and F mu is 0.1 and R is 800 sine theta. And sine theta value is given us here 0.8. So I'm replacing here 800 sine theta, and then I replace the values 0.1 into 800 into 0.8. So so this turned to be friction force is coming 64 newtons. Okay. Now, so what is the formula? Because we need to find out the speed just reaching, okay? If we apply Newton law technique, so U is 0, V is job to find, and distance is 5 meters. And if I get acceleration, question will be over, inshallah. So how to get it? So let's try. So when particle is traveling downwards, what we have situation. So have a look. What is this? mg sine theta. mg sine theta. What is the backwards? Frictional force. So I'm writing here net force is equals to ma. So mg sine theta minus friction is equal to ma. Mass is 80, and gravity is 10, and sine theta is 0.8. And wait a minute, sorry, I did mistake here. This is a cos, not sine, this is a cos. Okay, so I'm writing here cos. And same way here, cos. So friction change only. So here cos theta. And a cos theta, how to find, students? How to find, okay. So sine, what is the formula? You have many choices, but cos square theta is equal to 1 minus sine square theta. So cos theta is equals to root of 1 minus 0.8 square. So when I get it, this has become 0.8. So cos 0.8 comes here. So cos 0.8. So 0.1 into 800 into 0.6. We got a 48 friction. Okay, so this is a cos theta. Now this mg sine is mg cos theta. Okay, this is clear. So if I apply 0.8 in friction force is 48, if mass is 80, acceleration we can find from here. Just matter of typing in calculator 80 or 800 into 0.8 and minus 48. I got a 592 divided by 80. And I get the acceleration 37 over 5. So this acceleration will help us to get answer. So that's it. 2as is equal to v squared minus u squared. And acceleration is 37 over 5. And s we have 5 meters. Last velocity job, u0, take a root of the both sides. So, and I get what? Into 2 and take a root. So answers turn to be 8.6 in a root form. First of all, if I write, it's come root 74. And velocity becomes 8.60 meter per second. Alhamdulillah Rabbil Alameen. We can apply magic formula as well, students. If you want to apply magic formula, applied force, Victor friction force, kinetic energy plus potential energy, endpoint B, and starting point is A. So this K is at B is a job to find, so have mv square. And ground, we take this as a ground level, so this is height is 0, this is 0, and this is, we can find mgh. So because we can make this triangle, you can see on the top and make it easily. And friction force, you have it 48 into 5, you got a work done by friction force. And this is 0. Why? Because it's sliding down due to its own weight. So is a second option available? Okay, Alhamdulillah, I hope so. The concept is part is clear. And the part A is over. So let's go for part B. So it is given there's no change in the speed for the man when passing through B, and its speed at C is 11. So it means C speed at C is 11 and B speed we just got it 8.6. Now it is very clear the height is 2.5. So we can work with the magic formula. What is the magic formula? I said before in the previous part, work done by applied force, work done by frictional force, kinetic energy plus potential energy, and end point. End point is C minus kinetic energy plus potential energy. Starting point is B. So first of all, I will find all these parameters, then I plug in. Work done applied force is 0, so no need to find because it's coming due to its own weight. And work done by friction force, we can find it. Sorry, we have to find it. Work done against friction force from B to C. So it means this is our job to find it. And rest kinetic energy at C, is we can find it half mv square, half m. The mass is 80. Let me check once again. Yeah, 80. Mass is 80. So mass is 80, half mv square. And kinetic energy at B have m 8.6 square. And potential energy at C is naturally 0 because 0 height. But at B we can find it. What is the potential energy at B? mgh. M is 80, G is 10, and height is 2.5. So I'm going to calculate all values. 40 times 2, 11 square. I got a 4840 joules. Okay, 80 times 2, okay. And then 40 times 2, 8.6 square. And I'm getting here 2958.4. So 800 times 2, 2.5. And I got a 2000 joules. Right. Now I'm going to plug in all parameters in the top formula. So I'm bringing back this formula. Wait a minute. So this formula, copy and paste. Because why I call this magic formula? No need to memorize so many formulas what we need normally in a full chapter. This is 0 and this is my job to find. Plug in KC is 4840. PC is 0 because it's a ground level. Okay. And kinetic energy at B is 2958.4. And positive, negative, negative. So I get a negative here. And negative potential energy B is 200 joule. Okay. Let me just recheck once again. It's 2000, sorry, not 200. This is why a so small number as compared to others. Okay, now just matter of typing 4840 minus 2958.4 and minus 2000. And I'm getting here negative 118.4 and negative cancel from both sides, and work done by frictional force is 118.4 joules. And once again, I just check in calculator. So, so 4840, correct, okay. And 40 times 2, 8.6 square. So 2958.4, clear. And 800 times 2, 2.5, 2000. Okay, 4840 minus 2958.4. Just rechecking. And answer is coming 118.4. So Alhamdulillah Rabbil Alamin. I hope so. The point is very, very clear. Question number 7. A particle X moves in a straight line. Displacement from X to O is given by this formula. And this formula implements from 0 to 4. Okay. Before we start, I just always explain the students displacement. We have 3 levels. Displacement. If you differentiate displacement, you get a velocity expression. If you differentiate velocity expression, you get a acceleration expression. And this is called d over dt, differentiation, d over dt. If you want to come down, so integrate with respect to time. And when you integrate, you get a displacement, acceleration to the velocity, velocity to displacement. So let's start. Right now, I am on the level of displacement and I'm looking for velocity. So naturally, I will differentiate one time. So when differentiate, you know it very well. So ds by dt, and what is the basic criteria? This power 2 comes down. So it means 0.6 and power 1 less. 1 you write or don't write, no problem. And 0.6 remain that. So he said find the velocity when time is 4. This is called velocity 0.6 t and plus 0.6. And when I plug in time 4, sorry. So what I get velocity, let's see. There's a 4 and plus 0.6. So there's a 2.4 plus 6, we got a 3. So velocity turns to be 3 meter per second. I hope so the point is very clear. Part number next. And more than T4, it means this formula is valid from 0 to 4. And this formula is valid after 4. It's an acceleration and given this formula. So let's try to do it. A is equals to 0.3 t to power 1 by 2. And there's a no change in velocity when time is. It means this at 4. At 4, what is that velocity? I got it 3. So it means when time is equal to 4, velocity is 3. And it said velocity of x at capital T is 14.2. So it means when time is capital T and velocity is 14.2. So we have to find out unknown T. So let's try to do it again. We are on the level of acceleration. And naturally, if I want to velocities I need, so I will come one level down. And when I will come one level down, I have to go for integration. So let's try. So when I integrate both sides, so here I will get automatically acceleration become velocity and integral sign and power half of t. And what is integration? Increase the power by 1. I got a 3 by 2 and 3 by 2 same down and plus C1 or just C, no issue at all. Okay, see. So now I will plug in the upper parameters. So I will plug in V3 and before I plug in, I have to simplify. And what is simplification of this? You can check in calculator. So when I check it in calculator, 0.3 divided by 3 divided by 2, and I got a 1 by 5. Now I can plug in the values. So T is equal to 4, V is equal to 3. So when I replace 3 here and 4 to power 3 by 2, I will get a C value. And I bring this completely on the other end. So 3 minus 105 into 4 to power 3 divided by 2. And my answers turn to be 7 over 5. Don't leave it here, plug in back in equation. So velocity is equal to 1 over 5 t to power 3 by 2 and plus 7 over 5. And we have to plug in now this parameter here to get the unknown t. So I'm keeping this capital T and V is 14.2. So 14.2 is equal to 105 capital T to the power 3 by 2 and plus 7 over 5. So first of all, I'll bring it this side and then multiply by 5, the whole thing. And 14.2 minus 7 over 5 multiply by 5. I get a 64. And you know what, student, what algebraic rule, when a power goes there, power flips. So t is equal to 64 to power 2 by 3. 3 by 2 will become 2 by 3. And we type in calculator, we get a 16 seconds. So Alhamdulillah Rabbil Alameen, I hope so. This page is completely over. And now we go for next page total distance traveled between 0 to t. And it means that we have two situations. First situation is 0 to 4. We have this formula and the other formula. So let me write both formulas. S is equals to 0.3. Okay, I think we will go for velocity. Okay, so this is no need. This is already distance formula, but this is required to change. So this formula I need. So this formula I needed to convert into displacement. So copy from here, and I'm going to paste the next page. So this is a formula we have. Okay, but this formula is applicable after 4. Okay, so first of all, you know it very well, and that is a very important because again we have a 3 levels, displacement, then velocity, and then acceleration, right? I'm a velocity level. I need to come on displacement level, so I will integrate. Okay, when I integrate, students, what happens? Let's see. This is S integral sine 105 t to the power 3 over 2 plus 7 over 5 and dt. So when I integrate, what is the rule of integration? Increase the power by 1, so 5 by 2 and over 5 by 2. And 7 over 5 becomes 7 over 5 into t. Okay, this is clear. And plus C1. Okay, what about this? This is, if you check it, it 2 will flip up. And we got a 2 over 25. 2 over 25. Okay, 2 over 25. Okay, then we have a and once again I check it, 3 by 2. So 3 divided by 2 plus 1, 5 by 2. Yes, this is a correct. And okay, into 5. So 1 over this. Okay, this is correct. Now t to the power 5 by 2 and plus, and 7 over 5 plus C1. Now I have to plug in some parameters. And very important parameters on the last page available. And what is that? There's a very obvious, we need to find, because we have talked about distance. So when I plug in this 4 in this equation, I'll get a distance. So I'm writing here S is equals to 0.3 t square plus 0.6 t. And 4 I'm going to plug in. So first of all, I'm going to cut from here and bring on other page. Okay, so have a look now. So now I'm going to use it here. So I'm saying this is equation number 1. So here I'm doing it separately. Okay, so now when time is equal to 4, I get a displacement. What is displacement? Check it. I plug in every t by 4. You may ask what is the reason to put it this one, which I'm going to help you. Just wait. 0.3 into 4 square plus 0.6 into 4. And I'm getting here 36 or 7.2 meters. Basically, what are the criteria? I just tell you, look at now here carefully. From 0 to 4, when I reach, and after 4 is this. When time 4, let me show again. When time 4, velocity was 3, and displacement I got it at the same place is I just got it now, displacement 7.2. So we have 3 parameters here when time is 4 and S is equal to 7.2. So this parameter is helping for the next level of equation. So I can say here, now this is 7.2. Now here I will say, because I need to find C1, so previous parameter will help us to get this C1. How to plug in? So put T is equals to 4 and S is equal to 7.2. So when I plug in these parameters, so 7.2 and 2 over 25 and 4 to power 5 by 2 plus, there's a miss by T, okay? 7 over 5 and 4 and plus C1. So let's try to do it. And now I will bring this here and bring it here. And let me type in the calculator 7.2 minus 2 over 25 into 4 to power 5 over 2 and minus 7 over 5 into 4. My answer is coming with me. This is a C1 is turned to be negative 24 over 25. So this value I'm going to plug in it here. This is a very important concept, and many times students confuse here how they can get the value of C1. So I hope so. The point is very clear, and we got expression. This is expression. I got it purely for displacement. Okay, for 0 to onwards. Now, what a question he is asking for. Capital T, we have it. We have to find tills from 0 till capital T. And capital T, we just got on our previous page, if you remember, 16. So I have to use 16 and plug in there. So when I plug in, and because we're looking for displacement at time, so if t is equal to 16, so let's try to do it. I replace every t by 16, 5/2, and here 16, negative 24/25. So just try to just type in calculator. So 2 divided by 25 into 16 to power 5 divided by 2, and positive 7/5 into 16, and negative 24/25. My answer turns to be 103.36 meters. Basically, when I have used this T4 7.2, so previous distance, which is here, is automatically added in a whole journey. So that is why he said from 0 to T. So that is a very important concept. So I hope so you got the point. So first I found when time for what is displacement for the first 4 seconds. This is a very important, otherwise if you don't have a C1, you can't solve the question. So I hope so the concept of the question is completely clear and the paper is completely over. Best of luck for the upcoming exam. Assalamu alaikum rahmatullahi wa barakatuh.